Hello, and thank you for joining us today for our webinar, Integrating File Services to Power Your Media and Entertainment Workloads. I'm David Green, and I'm an Enterprise Solutions Architect here at Amazon Web Services. In today's webinar, I'm going to go over a high-level overview of AWS Cloud Storage Services while diving into file storage offerings, specifically as they relate to media and entertainment workloads. This will include some monitoring as well as some customer use cases. We're also going to save time for Q&A at the end, so please come up with any questions and submit along the way via chat or ask at the end. So, as I mentioned, I'm David Green. I'm one of the Enterprise Solutions Architects here at AWS, and in my role, I work with media and entertainment companies and help them align or modernize traditional workloads on the cloud. I also help prepare customers for large product launches, streaming, mass rendering, or VFX and animation. I love the cloud. Specifically, I love M&E workloads and what the cloud has to offer for compute and storage. I have managed on-prem storage and network environments supporting feature film and episodic television in the past, and previously, I needed to provision hardware in data centers and plan for peak capacity. So the storage that I deployed had to be able to support current workloads, to support our current projects and customers, but also be able to have enough capacity available to handle new projects or influx of peak projects. We never want to turn down work just because infrastructure wasn't ready, but also we don't want to spend more than we need to have excess capacity laying around. I also had to take procurement timelines into account. So this includes not only how quickly could I get a purchase order approved by the business, but also vendor lead time, all the way from hardware components down to adding power circuits, network infrastructure as needed. I love the cloud, but it's easier to love the cloud if you know what the cloud is. Cloud is an on-demand delivery of IT resources via the internet as a pay-as-you-go model. And this is particularly helpful for M&E workloads. And like I mentioned previously, where I had to allocate capacity, now I can just have a pay-as-you-go model for capacity, which makes things a lot easier. But don't just take it from me, you're in good company here. There's some of the largest M&E companies in the world leveraging AWS and our storage services to process and deliver content for their customers. Additionally, AWS has over 1 million active customers each month and across 190 countries. Media customers span from studios to broadcasters to pay TV operators, media service providers, sports leagues, publishers, and new media companies. So for a quick overview of AWS storage services, before diving in, I want to take a quick look at the higher level view of AWS services. This is a bit of an eye chart with a ton of stuff on here, so I just really want to take this to show you what AWS is doing. We have over 100 services that range from our core services such as compute, storage, networking, databases, all the way up to artificial intelligence, AI, machine learning, and specifically for media, we have products such as AWS Recognition that you can do image recognition and classification, also for videos as well. Our management tools offer a lot of insight and flexibility that let you manage your resources either through tools or management tools that you're already familiar with. And recent expansion into enterprise applications has been entirely driven by customer feedback and where they want us to deliver value. Storage fits in down here, and it's one of our core services. And at the fundamentals, we offer three main types of storage: file storage, block storage, and object storage. File storage is natively stored as files with a hierarchical directory structure. Each file and directory has a particular metadata associated with it, things such as the owner, group permissions, creation time. And in enterprise context, these file systems store data that can be accessed over a network by multiple clients at the same time. It's easiest to think of it as network attached storage. So it's a file server that you connect to, and you can browse it on your computer, drag and drop files to it, and that's what file looks like there. We have block storage as well. So block on our service is EBS. With block store, you have a set of disks that are usually attached to a computer, and data is stored on these disks using chunks called blocks. Operating systems work with these blocks by presenting the data in a file system format to users and applications. So for example, you can, traditionally you have hard drives that are connected to a physical host, whether it's a laptop or a server or a RAID array, and you attach these and you access them locally as disks. The third type is object storage. So with object, you access the data as an object, and it's identified as a unique key and value pair. So the key is the name, the value is the data of the object, or the file, if you will. And the object stores data using a simple API to put and get data based on its key. And this API is commonly accessed over the internet. So taking a quick look at performance comparisons. On the x-axis, we have latency. On the y is throughput. So block stores generally provide the lowest latency, but they don't scale to the same amounts of throughput achievable in file systems and object stores. Some examples of workloads that require low latency amounts are such as database applications and boot volumes, especially where data access is only needed from a single computer at a time. Moving to the right, file storage is generally designed for low, consistent latencies, but also designed to scale to tens of gigabytes per second of throughput. And object storage provides the highest levels of throughput and scalability, but it's not designed for latency-sensitive applications. So taking a look back at the three types of storage here and how they interact with other AWS services. So for example, we have many ways of moving data in and out, such as Storage Gateway, which allows for on-premises access to data stored on AWS, Direct Connect, which allows for connectivity directly to the AWS network from your network, which provides consistent bandwidth and latency characteristics. And on the right side, we have different security and management offerings. So such as Amazon Macie, which uses machine learning to identify sensitive data, CloudTrail for audit logging, and also CloudWatch for visualizing what's happening. So why file storage for media entertainment? File storage is really popular because it supports traditional NAS-based workloads. So for example, applications that require seeing a file system mounted to be able to access files or do rendering or processing, this works natively with AWS file services. File systems are the abstraction used to display data to end users, and operating systems use file APIs to allow applications to read and write data. Next, it provides shared access while providing consistency guarantees. So this means that if you have multiple systems that are reading and writing from the same file store, when you write data from one host, it's immediately available and consistent for everybody else. This is specifically important for workloads where you depend on data processed in one part of the chain to be ready and available for subsequent processing. So for example, this may include things for visual effects and rendering, where you're rendering out layers and components to be later composited. And it also provides a hierarchical namespace, which is a helpful and natural way to organize data. When we see customers building media applications on us, we see 7 main segments. These segments include acquisition, visual effects and editing, digital asset management and archive, digital supply chain, playout distribution, publishing, analytics, and OTT, or over-the-top streaming. Some of our customers build out 1 or 2 of these segments for specific offerings for their customers or for their business, but other customers we see build out everything as a full end-to-end service on AWS. When we overlay the storage offerings to these segments, we see the 3 types I spoke about before, such as EBS, EFS, and Object Store, S3 and Glacier. So for example, with acquisition, data can be landed on an EFS file system, and because EFS is highly scalable and allows for a high number of concurrent access, into hundreds or thousands of instances accessing the same file system, this scales really well across a whole area for M&E. So for example, data that lands can then be processed, for example, using dailies or watermarking for review and approval, and then visual effects and editing can access the same data on the same file system, which then could be output for archive or for further processing down the supply chain. So why do we see customers using AWS for M&E? A quick step back on AWS and our global infrastructure. So today, as of September, we have 18 regions globally, with 4 new regions announced and planned. We have 55 availability zones. So a region comprises of availability zones. At least 2, usually 3 or more, some as many as 6, some in a single region. And today we have 135 edge locations for our CDN. And I mentioned Storage Gateway and also S3 transfer acceleration. So transfer acceleration for S3 actually goes through these edge locations and allows for closer latency for your media transfers to come through our backbone. So we have to think also about the marketplace. There's several partners that you may be working with currently that have offerings in the marketplace. For applications that you want to run, media processing, and everything else from traditional IT, really across the board there. And also we think about distance and content gravity. So with distance and content gravity, you really have to think about the geographies that are most suited for your applications. For example, if you're doing post-production in California, you may want to have a presence in the US West 1 region in Northern California to provide low latency to your post-production facilities, perhaps on-prem. Also, you can use CloudFormation to replicate environments. So for example, if you wanted to take the environment that you had in California and move it to the East Coast, move it to Europe, Asia, South America, it's really, really easy to use infrastructure as code with CloudFormation to replicate full environments. And there's many options for cost optimization. So for example, we see customers that archive data to Glacier for the high resolution raw content and then edit on proxies, and then when they're ready to final, they can pull data off of Glacier and then run their processing. And there's also reduction in process across AWS as time goes on. There's been several reductions to date, and we always use economies of scale to allow for lower costs for our customers. So I know I mentioned AWS regions and AZs. I want to do a quick dive in to see what this looks like. As I said, all regions have at least 2 AZs. Many have 3 or more, some as many as 6. So for example, in the US, in Virginia, we have 6 availability zones to choose from. In Ohio, we have 3. And what really allows us to do is have customers that need to have redundancy. Use cases where they need to have multiple data centers for redundancy. Now you can do so with availability zones. So an availability zone is not just a data center. It may be a data center, but it may also be a cluster of data centers that's highly connected together with highly redundant networking. And it allows for very low latency between other availability zones and single-digit millisecond latencies, and an effective way to design high availability. So let's see how customers like to deploy on us. If you're running file storage yourself, maybe a do-it-yourself, you build it yourself on EC2 or virtual machines, and you can use EBS or block store. So I'm zooming into a region here to see what this looks like. We have, just for simplicity, I'm showing 2 availability zones, AZA and AZB. So we launched EFS about 2 years ago, and before EFS, if you wanted your own storage, you kind of had to do it yourself. And this is what it would look like. So typically, you would have a setup like this. We have our EC2 compute nodes that are accessing a file server on EC2, and also the storage for the file server is stored on block devices on EBS. You would run your own operating system, you'd create an NFS SharePoint, and then share it out to your compute. Well, how would it work if you wanted to scale past that? So let's say you wanted to take advantage of other availability zones, have a larger compute farm. You'd maybe do something like this. You have a file server set up in a second AZ, the same kind of thing. But of course, that doesn't work too well because, like I mentioned, our media customers typically like to have strong concurrency on the file system. So as soon as one file is written from one server, it's immediately available across everybody else. So you probably set up synchronous replication between the 2 of these. And this is definitely possible. We have seen people do this in the past. However, there's a lot that you have to kind of take into mind doing something like this. Yeah, your responsibilities here would include operating system management, updates, snapshots, block storage management, snapshots there as well, and file system snapshots. And also managing consistency between multiple servers is not, it's someone that you probably don't want to do. You probably want to focus on creating the best content possible for your customers. And also you have to worry about scale. So if you have a situation where you have a deadline or just a large project and you want to scale up to hundreds or thousands of render machines, scaling out your NFS backend up and down is challenging. And there must be a better way. And surely there is. That's Amazon EFS, which is our fully managed file service. And taking a look at how EFS architecture works. So EFS is a regional construct. You create a file system in a region, not a VPC. The VPC spans multiple availability zones, and your EC2 instances reside within a VPC. And these NFS clients gain access to the file system using a highly available network construct called mount targets. You create one mount target per availability zone, and they show up in your VPC in an Elastic IP interface. You can also associate one or multiple VPC security groups with your mount target to control access to your file system. And there's a single DNS name for each file system, and it's used to mount the file system by NFS clients. This architecture allows 1, 10, or thousands of instances to mount the same system and share a common data set. There's also no single points of failure, so it's highly scalable. The mount target is a highly available construct which allows for high concurrency to the file system from each availability zone. So some of the key features. When we first designed EFS, our core tenet was simplicity. It's a fully managed service. There's no hardware, networking, or file layer to manage. And with only a few clicks, you can create a scalable file system in literally seconds. Second core tenet was elasticity. File systems automatically grow and shrink as you add and remove files. There's no need to provision or capacity or performance. You only pay for the storage space that you use with no minimum fee. And finally, the third tenet is scalability. EFS file systems can grow to petabytes of capacity. The throughput of the file system can drive scale automatically as a file system grows, while providing consistent low latencies regardless of the file system size. Across the whole time, all these we want to be highly available and durable, and we designed EFS as a platform to provide high availability and durability, and EFS also supports 250 megabytes per second per instance, so it scales really well. In some throughput tests here, we show how multi-threaded access and multi-host access really drives the throughput of a file system. So I'll go through some best practices at the end, but at a high level, use multiple threads, write the multiple directories in parallel, and use larger I/O size where possible. Well, monitoring is also something that's important. By having monitoring, you can actually see what's happening on your system, such as total I/O, the data read and write, metadata I/O, and in the CloudWatch console, you can see in near real time your file system performance. Not just that, but these metrics are sent at CloudWatch at 1-minute intervals and are available for the next 15 months, so you can access historical information about the workload that ran on your system over time. And metric math is also a feature within the Amazon CloudWatch. It makes it easy to perform math analytics on your metrics to derive additional insights into the health and performance of your AWS resources and applications. What I've done also with metric math is you can have all your instances and then add it up or perform a math operator on it. So you can say, show me aggregate throughput for all these instances for the network, or all these for EFS or whatnot. There's some examples here in the link below on GitHub on our AWS samples page of getting this set up in a programmatic way. Well, I mentioned this before, where EFS with a few clicks is ready to go. You add files to it and it just runs. And there's no capacity planning, which is awesome. And I'm sure I'm not alone here. I had a plan for capacity based on projects we had, what we might have in the future, making sure things were fast enough, making sure that we were ready to handle new higher throughput resolutions and file types. And for me, it was hard to go back to the well to ask for more money after getting an initial PO to come back and say, oh, well, actually, I thought that I had this right, but I need more money to get this faster. In the old world, this is what it would look like. Let's say I procured a petabyte of raw storage, got it racked up in the data center, ready to go. After it's rated and really provisioned, let's say it got down to about 800 terabytes of usable space to make a file system or a SAN volume out of. Well, you never want to fill it to 100% full, so it's safe to have a percentage of overhead that you consider to be 100%. In this case, let's say 600 terabytes is your total allocated storage to your project or your file system. Well, what if my data set was only 400 terabytes? And I essentially have all this wasted capacity, not only of raw spindles, but just space that I can't use. But we're still paying for it. In the case I saw too, there are situations where time goes on where you're not filling it up yet, and then next thing you know, the new versions of controllers come out, new hardware comes out, and then what I have now is old and not performing as fast as the new hot stuff is. With AWS storage, this is not the case. With AWS, you only provision what you need. And within this talk, I'm focusing on Amazon EFS, and the storage is elastic. So that means you only pay for what's used on a per hour basis. So as you add and delete files over time, you only pay for what's stored. And this allows customers to really pay for what's used in an on-demand model. You pay no more than needed, and it's a different model than the world that I came from, supporting on-prem NAS and SAN infrastructure. So taking a look at a super simple sample production pipeline. We're going to do data ingestion, storing data, editing, and then processing. With ingesting data, we see customers that use Amazon EFS as a constant store for the data to be ingested to. So for example, media studios are fronting EFS using EC2 and Aspera for high throughput accelerated file transfer. Data can be processed on set, from the DIT, where they have data from the raw camera that goes to a local system on set, and then they use Aspera to move data across the world quickly to EFS, which then could then be accessed by other pieces of the post-production pipeline. Data is then stored on EFS. Like I mentioned, it could be also transferred over to S3 through EC2. You can write to S3, and that could be used to lifecycle to Glacier if you want to for either asset storage for the large raw assets, or for long-term archive. Editing is easy on EFS, so because EFS scales so widely, it can be spread out across multiple systems, and also EFS offers access to on-premises networks using Direct Connect. So that means that your cloud-based workloads can access EFS, and also on-prem you can mount EFS as NFS target across the Direct Connect. So it's really easy to do that. And then processing. And this is where things get really interesting. Because it scales out so widely, you can use the scale of EC2 as well. So as you scale EC2 to tens or hundreds or thousands of nodes, you can process your data on EFS really easily. So a couple best practices to go through. We suggest testing with general purpose mode. There's two modes. There's performance mode, and high performance, and general purpose. I would test there and start with the bursting that's enabled in EFS already. So as you add files, the larger the file system gets, the higher throughput happens automatically as it scales up. But we also have provisioned throughput in EFS to support small volumes with high performance. We suggest a Linux kernel of 4.0 or greater. There's an EFS mount helper. And large I/O size to really help for aggregate I/O against the file system really helps to drive high throughput. For the highest throughput, we see customers using multiple threads or multiple instances, which works pretty well already with media entertainment with large render farms. Reading and writing from multiple directories. So as you spread traffic across multiple directories, you have performance increase. This may be the case for assets such as textures or background plates that get spread in different directories, which is already pretty common of how data comes in from cameras on set. And also monitor metrics, right? So what gets monitored allows you to really see what's happening and provide the input to your insights into the performance of the file system. So a couple customer use cases. BBC Red Button. So BBC required a POSIX compliant file system. They started off by building their own file server on AWS, but they found the complexity and operational burden of supporting a custom NFS server 24/7 was quite prohibitive. EFS could be set up and mounted to EC2 within minutes, and you can read and write immediately from a number of EC2 instances. The use of EFS meant they did not have to rewrite a core component of their environment, and they could move quickly to meet their timelines. And Thomson Reuters. Thomson Reuters migrated to EFS, and they started with 2 on-prem data centers. These data centers had 120 systems in each, including firewalls, edge caching, and load balancers to send traffic to the healthy locations. And with EFS, they were able to have the capacity on demand, and they were confident they would never run out of storage space and no longer have to worry about aging hardware, warranties, support contracts, or hardware failures. And best of all, they were able to get the better service for 67% less. And there's a YouTube talk here from reInvent last year, available online, and the use cases for BBC is also available in the link below. So taking a look forward, you know that slide that I showed earlier that had all the services? It was that eye chart with tons of stuff on there. AWS regularly updates our services and launches new products based on feedback from customers, and we truly listen to feedback from customers to shape the roadmap. Last year alone, we launched 1,430 services or features, and this is growing year over year. We're also expanding into areas such as Internet of Things, AI for artificial intelligence and machine learning, and hybrid and enterprise applications. Some examples of this as it pertains to file storage is with EFS provision throughput. Customers liked EFS, but they said, I really wish I could have more throughput and not have to worry about the size of my volume that scales on my throughput. So we launched provision throughput. This allows you to scale independent of the amount of data stored, and you can increase as often as you need, or switch or decrease once every 24 hours. Another offering is Elastic Volumes with EBS. This came out a couple years ago, but I think this is worth noting. EBS Elastic Volumes allows you to change the volume type between SSDs or HDDs, and you can increase or decrease provision IOPS. And this is great because you can do it in production without having to worry about unmounting or taking downtimes. Another one that came out a couple years ago, but is definitely worth noting in this space, is Amazon Glacier Expedited Retrieval. So with AWS Glacier, Expedited Retrieval allows you to quickly access your data for occasional urgent requests. So for example, we see news organizations leveraging Expedited Retrieval to retrieve data when a story breaks and they have to pull back archive content. Prior to that, they had to go and get tapes, whether it's off-site in a vault or on-site, and load it to a library and get it online quickly. Now this allows you to get data back typically within 1 to 5 minutes. Storage Gateway is a hybrid storage service that enables your on-premises applications to seamlessly use AWS Cloud Storage. There's different modes that we support with Storage Gateway, such as file access, volume access over iSCSI, and virtual tapes, where we expose a virtual tape library so you can point your existing legacy backup applications to this, and it sees it as a tape library and LTO drives, and data stored goes to AWS. But specifically, Storage Gateway in file mode is great for M&E hybrid workloads because it exposes a one-to-one map from files to objects on S3. So this means that you access the data on-site or even on cloud through a virtual storage gateway. But let's say you're on-site and we're exposing either NFS or SMB, and you mount it like you would a regular NAS server on-site. The media upload goes through the file gateway and is exposed on S3 for either storage or further processing on EC2. And you can also have a tiering policy that can tier data from S3 to Glacier for long-term inexpensive archive. Both S3 and Glacier offers 11 nines of durability. And we see customers use this to either move data from LTO to a file type format so they can load data from LTO through their system through this device, and it lands on S3. And we also see customers use this as a data repository where it's almost like a bottomless NAS, if you will. So you have it backed by S3, and it's safe on S3, and we have local caching on the device on the edge as well, up to 16 terabytes of cache. And of course, there's AWS Snowball. So Snowball is storage that you can write to on-prem, and then you can ship it to AWS and have it loaded into AWS storage services. And it works the other way around too. You can have this Snowball move data from AWS back down to your location, and that could be used for situations such as disaster recovery or pulling data off of archive. So we launched Snowball in November of 2015 with a 50 terabyte version. A few months go by and we upgrade it to a 80 terabyte version. And then we also announced later the same year in 2016 a 100 terabyte Snowball Edge device. So the Snowball Edge includes onboard compute and also the ability to access the Snowball through NFS. And there's also a S3 endpoint on the Snowball as well for high throughput object access. And we see customers using this for on-site data writing. So they can ship this to the studio, and we can record data from camera, write it to this, and then ship it back to AWS for further processing, such as dailies or processing, or watermarking, review and approval, and whatnot. And talking about innovation, we had customers say, Snowball's cool. I have to move a lot more data, and I don't want to have to manage several 100 terabyte Snowball edges. So we launched the 100 petabyte Snowmobile, also in 2016. Snowmobile is a truck with storage. You can drive out to your data center, you can plug it in, and you can write data to it and move data just like you would a giant Snowball. And by the way, the Snowmobile is another file storage service of AWS as it supports NFS access. Thank you very much for your time today. I look forward to answering some of the questions, and please know that AWS will always continue to innovate on behalf of customers. And I specifically like media on AWS, not only for the huge customers using us, but small customers. It's a level playing field now, and you have the access to the same resources as these large studios have. So it's really easy to get out there, make the best content you can, and really focus on delivering great content and not worrying about the undifferentiated heavy lifting of maintaining infrastructure. Thank you very much.